think it's charging. Hi everyone, and welcome to the R in Teaching session. Just as a quick check, can people hear me from the audience? Yes, great. Okay. Thank you everyone for joining. So I'm Laure Cugnot and I will be your host for the session. And our first speaker is Amelia McNamara, and she's an assistant professor from the Department of Computer and Information Science at the University of St. Thomas in US, if I'm correct. So Amalia, feel free to start sharing, and good luck.
Great. Yes, I am going to try this again, and then let's do that. And hopefully you can now see my whole screen and everything looks good. So thanks for joining us today. I'm Amelia McNamara. I'm going to be talking about teaching modeling in introductory statistics. And the idea is this is a comparison of the formula and tidyverse syntaxes. I just tweeted a link to the slides if you want to follow along. So you could go to my Twitter, AmeliaMN, and there should be a link. And this is basically based on a paper that I wrote. There's a preprint available on the archive if you want to dig into this more. Before I get started, I'm just going to say I'm using the Palmer Penguins data, and I know we're going to hear much more about the data set later in this session, which I'm really excited for. So I won't say too much about it right now, except I love it as a teaching data set and to use for demonstrations. So just to set the stage, if you are an R user but you haven't thought about the idea of syntaxes very much before, I think of three main syntaxes in R. So there's the base syntax, which comes with R when you just install it. There's $signs, there's square brackets. That's kind of how you characterize the base syntax. And then I focus mainly on the formula syntax, which is the one that has the y tilde x layout, and the tidyverse syntax, where you have the data first and you can pipe things through a pipeline. So right here, I'm just showing you how to do some summary statistics in the three different syntaxes. So for example, if you wanted to find the mean of body mass G based on species from the penguins data, you could do that task in these three syntaxes. You're going to get basically equivalent results, but the way that the code looks is pretty different. And I specifically chose a multivariate example here because when we're teaching statistics, the GAZE guidelines tell us that we want students to be thinking about multivariate problems. Similarly, if you were going to make a scatter plot, you might use the plot function in base R, plot penguins $flipper length comma penguins bill length In formula, you might use the GG formula graphics. So that would be like GF underscore point, bill length tilde flipper length data equal penguins. Or if you're using tidyverse, it would be like GG plot of penguins plus the geom point with the AES specified there. If you wanted to take that even further and break down that relationship between bill length and flipper length based on species, here is the syntax for how to do that in the three syntaxes. And I think that this is starting to illustrate the reason why I don't think about base as a way to teach introductory statistics. So if I wanted to compare the relationship between flipper length and bill length of penguins between the three species, that code gets pretty complicated. It gets repetitive. It's got this par mf row thing versus the formula syntax or the tidyverse syntax where it's much more succinct. And I think it's more clear what's going on. Even beyond that, you get pretty different graphics through these different syntaxes. So in the base syntax, here's the result that you would get. So you get the three plots. One thing I'll note to compare between that and the one that you'd get from the formula or tidyverse, they basically, if you're using GG formula, give you the same plots. Formula and tidyverse standardize the axes by default. So I can see that the chinstrap penguins and the Gen 2 penguins are bigger overall than the Adelie penguins. Versus in base, it is making the axes independently for the three different graphs. And of course, I could have standardized that, but it would have made the code even more complex. So there's some debate in the stat ed community about which one you should teach, and particularly in the first course where people have never done programming or statistics. I think all three syntaxes have their proponents, but usually the people who are really invested in pedagogy argue about if formula or tidyverse is best. So I haven't heard a good pedagogical argument for the base first approach. Usually if people are teaching base first, it's because that's how they learned. And that's not a great reason to keep doing something just because that's the way it was done in the past. Jeff Leake has a nice argument for base graphics, but I don't think that anyone is saying like you should teach all base in intro stats and basing it on pedagogy. I think the tidyverse philosophy is pretty compelling. In fact, Mina Chetinka-Rundell, Joe Harden, Ben Baumer, myself, Nick Horton, and Colin Rundell wrote a paper which is in ties called An Educator's Perspective on the Tidyverse. And then there's also the formula first philosophy, which is the third way. Nick Horton wrote a paper, and it's sort of the mosaic package idea. So that's Randy Prime and Danny Kaplan, and Nick Horton wrote the mosaic package. So I think, again, tidyverse and formula have good pedagogical arguments about why you would want to use them in your first course, but we don't have very much data, and we're statisticians, so it would be good to have some data. So I decided to do a head-to-head comparison. I had students who were enrolled in the same lecture class, so a group of, I think, 90 students. It was broken into 3 smaller sections so that they could do their lab material, and I taught 2 of those sections. They were both supposed to be R, so I just flipped a coin. One was tidyverse, one was formula. And they were pretty similar groups of students. They're mostly business majors. They mostly have not ever programmed before. Anyone who had programmed before did not have experience with R, so there was no prior experience in R. And the question is, why do this? Well, the first reason is to get some data so that we can have some grounding for some of these conversations. And then I think the other reason is that constraints breed creativity. So I told myself, in this section, I'm only going to be doing tidyverse. In this section, I'm only going to be doing formula. And I was trying to keep the number of packages really minimal, the number of functions really minimal. And that forced me to be really intentional about the code that I was teaching. And I think that led to a better student experience. So I gathered a bunch of data. I have my R Markdown documents and the code. I've got a pre and post survey. I've got YouTube analytics. I've got RStudio Cloud analytics. And I think maybe the coolest thing that I did was I used the get parse data function. Sean Cross, shout out to Sean Cross for telling me about this function. It's from utils, and it allows you to parse R code, and then you can kind of do stuff with that parse tree. So here's some code. It's a little incomplete. I took my R Markdown documents, I purled out the R code, and then I used the get parse data function to just get the parse tree, and then just filter out the functions that I was using. So to me, this allows me to have a minimal reproducible stats course, like a minimal reproducible example. So this isn't a new idea. Randy Prime has enough R for intro stats, which is the mosaic version, which is kind of showing all the functions you would need to teach an intro stat course. This is maybe even more specific because it's not just like any stat course, it's my specific stat course. I was able to see that in the formula section, I showed them 37 functions over the course of a 15-week semester. In the tidyverse section, they saw 50 functions. And there was an overlap of 18 functions that both sections saw. So neither of those numbers are very large. Sometimes people argue against the tidyverse by saying, oh, there's so many functions in the tidyverse. Yes, there's lots of functions in R, but you are not going to show your students every single one. In fact, constraints breed creativity. You should try and make it minimal. Of course, the functions that everyone saw were like library and set seed and mean and SD and LM, things like that. And some of those are just kind of helper functions that students didn't think about that much. Others are things that they became really familiar with. And then the other thing that I think was useful about this exercise, the head-to-head comparison, is that it allowed me as an instructor to think about what was hard and what was easy in each of the syntaxes. I had taught these syntaxes previously, but not at the same time, sort of in the same week, thinking about the same topic that was really standardized. So in the formula syntax, I think the hardest thing was dealing with missing data. So you could use options na.rm = true, set that at the top of your script, and then it is going to sort of inherit down. You could also set it on a per function basis, like in this mean function. It's not totally consistent because core has use equal, and you might want complete obs or everything. There's a few different options there. And so this was something that was like kind of hard to tell my students about because it wasn't the same everywhere. So I think a solution would be to have more consistency in the prep. So I kind of accidentally showed these 3 different things, but if I had been more intentional, I could have avoided that. Another option would just be to teach some data wrangling, which I didn't do in this course. The data that they got was pretty clean, but I could have done that. And the third option is question mark, you could maybe help me figure that out. In the tidyverse edition, I think the thing that was the hardest was explaining things that had 2 categorical variables. So like a two-way table or doing inference for a difference of proportions. Hopefully you can see here on the left, when I do my summary statistics, I have to think about, okay, 0.567, 56% of what? And sort of say, okay, of the females, and then these different islands. Versus in the formula syntax, it was more obvious what was going on because you actually got a two-way table. And then I think the infer prop test function is also a little bit tricky. It's kind of hard to tell if you've done it right because it doesn't give you the test statistics, versus in the mosaic prop.test function, you see those sample estimates, and then that can help you really know that you've done things right. So that was a thing that I struggled with, was working with 2 categorical variables. I have some data. It's a little blurry. I apologize. I did a pre and post survey. It was not that useful. So I didn't see much difference between the sections in the questions that I asked them. These are based on the Carpentry pre and post survey. And even when I combined the sections together and looked at the pre and post, there wasn't a huge amount of change with most of these questions. The only one is my students did seem to feel more confident about programming by the end of the semester, but things like being able to search online, that actually got worse. I think because if you are Googling, you're going to see other syntaxes and just be like, what is happening? I had data about my lab lengths, so my R Markdown documents in lines. I also parsed that data. As probably will not come as a surprise, the tidyverse labs tended to be a little longer in lines because of the breaking up with pipes. The videos, pretty much the same length with the exception of whenever I had to talk about 2 categorical variables, tidyverse a little longer. And then the thing where I found some interesting differences was actually in compute time. So I had students working on RStudio Cloud, and that meant that I could see how many hours they were spending on RStudio Cloud each month. And I lost the tidyverse data in November, very sad, but I think you can see that in October and December, the tidyverse density looks shifted over. Those students were spending more time on RStudio Cloud. So I actually fit a linear mixed effects model, looking at the interaction between tidyverse and formula and the month. And I've got some confidence intervals here. I think, let's see if I can find the interesting ones. So in September, no significant difference. The formula syntax stayed pretty consistent over the course of the months, but comparing the tidyverse to the formula syntax, those bottom 2 coefficients, in October and December, the tidyverse was using significantly more compute time. So I think the question, after seeing all this data, is which of these syntaxes should I use? And I don't have an answer for you. I would say it depends. This past semester, I had the opportunity to teach the R labs again for these students, mostly business majors, who don't go on to another statistics class. They're mostly kind of using R as a piece of statistical software. And I chose to use formula with them. I was like, I don't want to explain that categorical variable stuff. I want reduced compute time. We're going to use formula. But if most of my students were statistics majors, I would definitely teach the tidyverse. If I was teaching intro to data science, I would definitely teach the tidyverse. And a main reason for this is just the wrangling piece of it. I did no wrangling in this head-to-head comparison, and there's no formula way to do wrangling, so you're going to have to do tidyverse. And so you should just go all in on it. My biggest suggestion, my biggest takeaway for you is be consistent. even if you are like, I don't believe this argument at all, I'm going to keep using base R, try and constrain yourself. If you're going to use base R, only use base R. Try to always do the dataset $ variable name kind of syntax. So use those constraints to breed your creativity, and maybe try using get parse data to learn how many functions you're exposing students to. If you want to learn more, like I said, there's a preprint of the paper. I've got the code that generates the paper on GitHub. I've got my pre-lab documents and the cheat sheets, and I'm happy to answer any questions. So thanks for your attention.
Thanks a lot, Amelia. You're just on time. So we have 5 minutes for any questions. I don't see any question yet from the audience, but feel free to send them out in the Q&A session or in the chat. And I will be happy to transfer it to Amelia.
I don't know if that means that everyone's just been totally convinced to not use base, or they're still waking up in whatever time zone they're in.
I think the presentation was very clear. So if there is no questions from the audience, maybe I do have a question. So you mentioned that some of the audience also know maybe some other programming languages. Did you try to have a look if there was some links between the preference towards one of the two or the three approaches you mentioned and the use of experience of a programming languages? Or
I didn't look into that. So the prior programming experience, I'd have to look. I think it was like C++ and JavaScript and HTML, things like that. So I suspect that it was students who had done a programming class in high school. Based on those languages, I don't think that it meant that they had taken the intro computer science course at my institution. And I guess, the IRB, the Institutional Review Board approval that I had for doing this research was pretty limited, and I wasn't able to look at student outcomes data, but I would say that my sense is that those students who had prior programming experience, there wasn't much difference in terms of like their fluency with R, or like how quickly they picked it up. Yeah.
Thanks, Amalia. We do have a first question from Thomas Stewart, who is asking, when teaching data science students, could there be an advantage of teaching multiple syntaxes?
Yeah, so I mean, I think that there's definitely an argument to teaching multiple syntaxes. I think that practitioners are really using all three syntaxes likely. I definitely use the $ sometimes, and square bracket indexing. I'm a pretty tidyverse heavy person, but I haven't gotten into tidy models, so I do my LMs and GLMs and things with the formula syntax. So I think that once you're a practitioner, you're using all of the syntaxes. My opinion, and again, I should try and gather some more data on this, is that when you're learning, it is easier to learn if things are really consistent. So with the formula syntax, it's always y tilde x, and so students will be like, oh, I need to make a scatter plot, GF point, and the stuff that's in the parentheses goes into the LM when they want to do their linear model. It goes into the core function when they want to find a correlation. And so like the stuff that's in the parentheses is super consistent, and then they're kind of able to think about functions as kind of the actions that they want to do. So my opinion is, in a first course, teach just one thing, and then when they get into a second course or a third course, then of course they're going to be seeing multiple things, but it'll be easier to build on that once they have a solid foundation.
Thanks. A second question from Lance Dooley, who is asking, when examining the result for how much time students spend in base R versus tidyverse, did you take into account the grades the students got? For example, maybe the A students who are spending most time because they really enjoy working with tidyverse.
Yeah, so I think there's two things. One, I was comparing formula and tidyverse. I haven't taught just base R, and I was not able to look specifically at grade data. That was not covered. So I think it would be interesting to know what that relationship is between compute time and grade. The other thing that I wish that I would have, sort of figured out that I should have done ahead of time is some interviews with students, because I don't have an explanation. Like, I have stories that I can make up in my head as to why there was more compute time with tidyverse than with formula, but I don't know if it's true, right? It could be, oh, the tidyverse is so hard and I'm sitting and struggling and that's why I'm spending more time. Or it could be, whoa, this is cool. I want to play around with this. I'm gonna stay on RStudio Cloud and try some stuff out. And I don't know which one of those it is.
Okay, thanks a lot, Amalia. So I think we just sometimes there is one extra question in the Q&A, so feel free to reply there. Okay, great, thanks. So our next presenter is Jonathan Love, who you can see is online. Jonathan, can you hear us?
Yes, sorry, I can. I'm here.
Okay, no problem. Yeah, the video is great now. So yeah, if you could share your screen. So Jonathan Love, he's a software developer and researcher at the University of Newcastle, and he will present today about Jmovie, which is an R-based statistical spreadsheet for the masses. Jonathan, up to you.
So it is a little bit funny because I'm in the teaching in R session. Traditionally, my pitch with Jmovie to people who maintain R packages is that Jmovie is a way that they can make R packages accessible to people who don't know R. So there's a sense in which I'm sort of doing the opposite for the rest of this session. I'm making it possible for people so that they don't need to use R to do things. So I sort of apologize for the peculiar mismatch between my talk and the rest of the session. However, I think there are ways in which I think Jmovie can facilitate teaching, and I'll touch on those in the talk. But yeah, let me share it with you now anyway. Demonstrating Jmovie, but before we get started, I just want to prime you into thinking about Jmovie in a particular way. So yes, Jmovie is a fully self-contained desktop application, but it's also a web application accessible from the web browser. So rather like RStudio, we come in three flavors: a desktop version, a server Docker container version, and a public cloud version. And so the cloud version is actually running at cloud.jmovie.org. So if you get bored during this talk, or perhaps even interested, you can head over there and take a look. I'll be demoing the desktop version today, but I'm actually far more excited about the web version. To sort of give you a quick taste of what we're doing with the web version, here's Jmovie embedded inside an R Markdown document. And here it is embedded inside JTOS, a psychology experiment web service. And so a lot of what we're on about is facilitating these interactions. But the emphasis of today's session is on being a GUI for R. So I guess that's what I'll talk about. So this is what Jmovie looks like. You'll notice that we're very unashamedly a spreadsheet. But as you'll see, what we've tried to do is we've tried to make it very easy to mix and match spreadsheet and R programming concepts. And that'll hopefully come clear to you as I demonstrate. So it's probably easiest if I start with an example data set. And so we use these tabbed sort of interface. So, we've got the variables tab, which gives people an overview of the columns in their data set. We've got the data tab, and this includes a range of data and transformation type procedures. So you can recode data, you can compute new variables, you can even filter out rows and things like that. Coming over to analyses, we've got a range of analyses available. So under exploration, of course, we've got descriptives, we've got t-tests, ANOVAs, under the linear regression, frequencies, factor analysis, etc. And of course, if Jmovie is missing something you need, you can always come over to the Jmovie library and find it there. So the Jmovie library is a bit like CRAN or CRAN for Jmovie. It contains a whole list of additional modules that you can install to provide Jmovie with more features. So what I'll do now is I'll install this one here, the RJ editor, and this allows us to run R code directly inside Jmovie. And so you'll see now that's complete. It's created this additional icon here. But let me come back to that. First up, I just want to run some descriptives. And so what I can do is I can just pop things from the left over to the right like this. Maybe I want some frequency tables. Maybe I want a box plot or box plots. Yeah. Really, this is more of an ANOVA data set. So maybe let me run one of those. And again, I'll just pop things from the left over to the right. Maybe I'll plot some estimated marginal means while I'm here. But the order here is not quite right, so let me just reorder them. Yep, that's looking good. So now I'm here, let me just show you our first R trick. What I can do is I can come up here to the syntax mode, and you can see what that does is it creates this little block of R code at the top of each analysis. So I can take this, I can copy it, and then I can come over to RStudio, and I can paste it in here like this. Let me update the data set we're using. And so if I run that, you'll see that I get exactly the same analysis and the same plot and everything. So yeah, so that's quite nice. So we've tried to make it really easy for people to be able to run their analyses and then move over to R if that's what they're wanting to do. So that's the syntax mode. Lastly, down the bottom here, I've got this option to save the residuals. So I'll save those. If I come back here, you'll see that this has created an additional column in the dataset called residuals. What I'll just quickly do is I'll come back up to these descriptives and let me pop these out. And then I'm going to pop the residuals in there like that. Now let me come back down to the ANOVA. Now let's think about it, right? This is a spreadsheet. So let's have a think about what needs to happen if I change this value here. So what I'll do is I'll just change this value to something silly, 1,000, so that the change is really clear, and hit enter. And so hopefully what you're seeing is that the ANOVA is updated. And then because the ANOVA updated, it writes a new set of residuals to this column here. And then because the residuals changed, the descriptives responded to that. So the descriptives have recalculated, and yeah, you can see row 9 corresponds to this outlier here. And of course I can come back down here, I can undo my change, and we're back the way we were. So that is the spreadsheet side of things. Now what I want to show you is the R side of things. So I'm just going to start with a new data set. And the first thing I'm going to do is I'm just going to delete these 3 place marker columns. And then I'm going to come here and I'm going to run the RJ editor class. Let me just shift this over here and shrink this up. And what I'm going to do here is I'm just going to read in a data set from the internet using the Rio package. You can probably tell I've got one of those mechanical buckling spring keyboards. Okay, and here we are. We've read in the cars data set. And so, I can go on and I could run a linear regression if I wanted. Maybe I'll look at miles per gallon as a function of horsepower. But of course, I can run exactly the same analysis in R. So let's do that now. So again, let me just bring miles per gallon and horsepower across. And then I'm going to go model. I'll define my model using the LM function. What do we say? Miles per gallon as a function of horsepower. And let's run that. And so when we do that, we get this 30.08989 for the intercept, and we're getting the same results. Actually, let me put on the show code and output so we get the code as well. What else can I do here? Oh, well, maybe I want to save the predicted values from the model back to the data set. If I run that, you can see that's what we're doing there. And, you know, we can do any sort of R stuff we might want to do here. So maybe we want to plot the predicted values against the residuals of the model, like so. And that's what we get. But yeah, but that is the sort of the R side of things. And hopefully you can see that we've tried to make it as easy as possible to be able to mix and match the concepts from both the spreadsheet and from R. And that's basically my talk today. If you want to learn more about developing modules for Jmovie, we've got great tutorials at dev.jmovie.org, and we've got a great community, so we'd love for you to come and join us. Thanks.
Great, thank you, Jonathan. Great talk. Yeah, I think we have plenty of time for questions. So if anyone from the audience would like to ask a question to Jonathan, feel free to ask it in the Q&A session or in the general chat.
Yeah, I have a question. When you install your program on the desktop, is R parallel installed or is it part of your installation?
It is part of the installation. So Jmovie has its own version of R, which it runs inside itself. I didn't show it there, but with the RJ editor, you can set it up to use the system R as well. So
does it work well? So if I have R installed already and I installed Jmovie, do they work well together if I still want to use both?
Well, by default, they're completely independent of one another,
okay.
so there's no problem.
Oh, that's good.
Yep.
Great.
Yep, exactly. So, but yeah, but RJ has the option of being able to reach out to the system R if that's what you want to do. Yeah.
Okay, a question from Paul Harrison from the audience. Does Jmovie have a preferred data layout, wide or long, tidy?
It's mostly wide. There's a massive body of SPSS users out there, and that's essentially our sort of target audience. And so to bring them over the line, yeah, so and yeah, in SPSS, you're very often dealing in the wide format. It is a weakness of Jmovie at the moment. We don't have good restructuring from converting from wide to long formats. That's something we'll add in the coming months. But yeah, it's mostly wide, but there are some modules that work on the long format. So yeah.
Okay, thanks. Second question from Jeff Stevens, who would like to know, he mentions that Jmovie looks a bit like JASP. What are some similarity and differences from JASP, if you know this one?
So I was the original developer and designer of JASP, and JASP originally stood for Jonathan's Awesome Stats Program. So it's a, yeah, I suppose JASP was really designed to promote sort of Bayesian methods, and so we did that for a number of years. But in the end, we really wanted something that was more community driven, I think, in the end, and so that's why we left and started Jmovie. But I think the big things that I don't keep a very close eye on what they're up to, but I think the big ones are the data editing, the web-based angle. The web-based stuff is really important for us, and I don't think they have they don't do that. What else is there? Yeah, I'm not really sure, to be honest, but yeah, there's a number of ways in which we tend to be quite different. But yes, the designs are very similar, and that's because it was designed by a very similar set of people.
Thanks. Thomas Stewart would like to know, he's teaching for many different audiences, for example, different type of students. For which audience is Jmovie the best suited?
I'm from the social sciences, so I'm from psychology. I think for your less technically minded student, I think that Jmovie can be a really good fit. And so when you think about it, intro stats program at most unis, there's masses of psychology students. Then there's, you know, a small number of speech pathology, a small number of nursing even, sort of thing. And I think often for these people, learning something like R is probably more than they need, and you might be asking too much of them. That might be a contentious thing to say in a forum such as this. So yeah, I think wherever the technical standard is lower, I think something like Jmovie can be a really good.
Great, thanks.
I just noticed Cameron's posted in the chat blog here that he's a fan of the Learning Statistics with Jmovie textbook, which I did have time, I probably could have spruiked it during my talk, but yeah, there's a great set of community resources, and Learning Statistics with Jmovie is one of them. So yeah.
Thanks. Maybe a question from me. So is it possible to extend Jmovie to create your own plugins? Or?
Yeah, absolutely. And that's sort of a big part of what we do, has been facilitating that. So I think we've got about 40 or 50 modules now that people have contributed, and yeah, and so that's it's just been really exciting to have the sort of community grow around Jmovie. But yes, so we've tried to make that quite straightforward, and it doesn't require too much effort to get something that's, you know, really nice looking and really nicely behaving within Jmovie as well. So yeah, the itch that I'm normally trying to pitch Jmovie to scratch is you write R packages. This can be made accessible to a larger audience if you turn it into a Jmovie module. So yeah.
Okay, thanks. We still have a few minutes. You were really effective in your talk. So yeah, is there anyone from the audience again who would like to ask anything to Jonathan?
That's no problem. I did actually record a longer talk, and then I was really unhappy with it. I thought, I feel like I've said so much more in the short talk. I'm just going to do the short talk, and I'm glad I did. I do think it was a better talk, but I appreciate it may leave us with some awkward silence we need to fill.
No problem. Any other question, maybe from the speakers or anyone? Maybe a question from me. Have you tried to deploy it with Docker? Is it compatible with Docker? Or?
Yeah, so we have, yes, absolutely. So you can, I might even let me share my screen. Are you able to see that? No, you're not. Oh, I'm glad that my share screen window into my wants to share the contents of your screen. No, sorry. But yes, basically we have a Docker container. You can run it, and then you can, of course, connect to it using a web browser. You can run it on your server if you like, and make that available to people like that. So yeah, absolutely. Yeah, Docker is such a fabulous technology. Yeah, it makes this sort of thing really easy. So yeah, we can certainly do that.
Okay, thanks, Jonathan. I think we are good on time. Thank you for the quick talk and the questions. So our next speaker will be Karsten Lange. I hope I said your name correctly. He's a professor of economics, and he mentioned also that he's enthusiastic about teaching with R to introduce the power of data science to students. So yeah, Karsten will present. Maybe you can share your screen. That works.
Okay, I hope you all can hear me.
Yes.
Yeah, I'm coming after we heard about Jmovie, which is a standalone software, big and great program. I go exactly in the opposite direction. I have a very small package here, which I purposely kept very, very simple. And it's available on CRAN. I updated it 2 weeks ago. I will make a developer version for new updates after this talk. If you have questions, if you have ideas, just send them to me. So the idea of this presentation is I don't want to present the tool itself. I want to present teaching strategies, ideas how to use it. And if you have questions about the tools, it has a help system. And because the tool is simple, the help system is simple. So you just type !teach hist, and then the tools come up. I'm using here, you see it already, I don't use RStudio, I use Learn R because I can execute code inside my presentation. It was a little bit bumpy when I tested it, so I might have to switch back to RStudio, but normally it works pretty well. So what are the requirements of a teaching tool? Well, it should be visual because we present it on a big screen to the students. And I think very important is it has to be very easy to use, because the worst thing that can happen, you present in front of a class and you fumble with your R code, you make mistakes, and even if it takes only 1 or 2 minutes to correct it, students get distracted. The code must be easy to understand by students, so they should know what's going on. So what teachhist is doing, it's a ggplot implementation, which makes it visual and nice by definition. The credit just goes to ggplot. But it is easier to use because it just focuses on histograms. And 2 or 3 topics are covered with teachhist. One are just regular histograms, so counts, relative frequency, or density histograms. Then there is a tool to demo confidence intervals, and one tool for hypothesis tests. And I will present a teaching strategy or example for each of them. So let's start with the count histogram. I usually get some data from my students, something like height, where nobody has problems to report it because it's observable. So I can import data here from a tibble or from another data frame, and the column where the data is are height. And I usually have 2 axes, a z-axis and an original axis. You will see that later on. For this example here, I switch off the z-axis. So if I run the code, here we are, you can see from the first command, it reports the mean and the standard deviation, so students know what that is. And the way it is designed, the mean is always in the middle of the histogram, which is not necessarily the case if you use ggplot directly. And the bin width is by default always 1 standard deviation. You can change it, but by default, it's 1 standard deviation. Another way to use data is, instead of using actual data, somebody can simulate data. So we get rid of this one here. And we type in the mean. Let's say from the internet, I find out the mean of all students is about 69. I just made it up. It's not correct, but the truth is pretty close to it. Standard deviation is 4. Now I work with simulated data. teachhist automatically simulates about 1,000 records, but you can change it. The z-axis is set to true, but because this is the default, we don't need it. So I run it here. And yeah, I have a typo here. That proves it's live. Here we are. And I have my diagram again, but now I have a z-axis, and I think that is really something that helps students. Students have so many problems with z values. So here we can say the deviation from the mean is 0, and then we can say here we are 1 standard deviation below the mean. We are 2 standard deviations below the mean. We are 3 standard deviations above the mean. And I think that visualizes z values way better. In class, I would go to the table and show them that these values match also in the table. Where I want to warn you, because these are simulated data, every time I run it, I get slightly different data. And in many cases, you don't want that. So what you can do is you can add a seed value that resets the random number generator. And what I also do if I present to a bigger group of students, I like to have the fonts a little bit bigger. So I run this here and you see everything is nice and big. Now I want to switch over to relative frequencies, and students should see how close this is, how similar this is. So here's the old code again. I run it. And now I would tell my students, look, 320, 362, this is really something that is not easy to digest. We don't get a feeling for it. How much nicer would it be if we have the height of the bars presented by relative frequencies by percentages? So the only thing I have to do here, I change it to relative frequency here. And I better delete these 2 parentheses. And I run it. And then I can tell students, look, this is so much easier to digest if I have relative frequency. So they get a gut feeling for it. Of course, this is not rocket science, but it helps especially the more medium statistics students, the beginning statistics students, to understand the concepts. So what I can also do, I can explain the rule of sum for normal distribution. And just as part of the convenience, I can add lines here, and I do that. I add a line, v line 1 at 61, at a height of 61, and another one, v line 2 at a height of 77. These are 2 standard deviations. It just makes it easier for the students when they sit in the last row to read the diagram. So now if I say 1 standard deviation away from the mean is 68%, that's easy to see because it's just 2 blocks. But when I say 2 standard deviations away, then these vertical lines help me. You can set your vertical lines wherever you want. Students will see it's not 95%, it's 96%. I could change this seed value, generate new data. They would see it differs with the sample. The rule of thumb does only apply approximately. So the next step would be, I want to go from density, I want to go from relative frequencies to density. How can I do that? Well, I want to print the densities here. Actually, I want to change the numbers first. So I want to show them, I want them to focus only on 1 bar. So I want to focus them on the bar that goes from 69 to 73. I update. Here we are. And now I can tell students, look, densities are so simple. They always have problems understanding that, at least in my class, in my experience. Densities, as little sense as this makes, it's just like the probability or the relative frequencies divided by the bin width. And the bin width is 4 here. So I should expect to get 0.09. So then I just change the command here to densities. And I add print densities, because the densities by default are not printed, because it's kind of confusing to print them on top of that. Print densities, set this to true. And again, I would tell the students what to expect, and then I execute the command, and students see, this is what we have here. So the next step, what I could tell students, I could say, look, the height is relative frequency of this bar is relative frequency divided by density. The width is density. And so the area, because then the width cancels out, is relative frequencies, and you have it here. And because densities are almost meaningless by themselves, I will take them out here and then discuss this here with the students. And of course, we don't have the time, but what I do is I ask students to develop their own z-table based on this graph. And I would choose a bin width of 0.5, so it's a little bit more complex. Takes a while as an exercise, but students actually learn a lot from that. Okay, let's go to the confidence interval. What I have to provide is the mean and the standard error. I use the standard error here as an argument rather than the standard deviation. I could have used standard deviation and calculated the standard error inside the tool, but I don't want this black box. I want students to calculate the standard error. They can either provide it as a number or here as a formula, standard deviation divided by my n. I had 34 students. And if it's a t-distribution, I have to set is standard deviation estimated to true? And of course, I have to provide a degree of freedom, what I do here. If not, I would just delete this here, and then it uses the z-distribution. I stick here with the t-distribution. Students can see the confidence interval. I can explain it to them. We have a lot of helplines here. We have the mean here, the calculated sample mean. We have the boundaries of the confidence interval. What I like to do is to show them if the sample would be smaller, if the sample would be only 9, and my common mistake is to forget to change the degree of freedom, that would be 8, then I would tell them, look at the confidence interval, look what's happening. And students see it extended. So smaller confidence interval, I can get it with bigger data. And the last thing I like to cover is hypothesis testing. And what you need to provide for hypothesis testing, I start with a two-tailed test. You have to have the null hypothesis. And we assumed, again, which is probably not true, that from the internet, we got that students' height is 69 inches. Standard deviation, standard error we provided based on the sample here. We provide the sample mean. Again, you could use z values, but we use t-distribution here. So this is true. Degree of freedom is 33. And the test type is both tails. So I can also use left tail and right tail. And I set my axis font in a way that's good to see. And this time I work with bin width of half of a standard deviation. I run it, and students can see here immediately that they do not make it with their sample to the rejection zone. So we're inside the green area. We're not able to reject the hypothesis. I can do the same thing with a left tail test and a right tail test. What I want to do is I want to run a left tail test here. And Why I do want to do that, because it doesn't make sense to run a left tail test here for that system, for the setup. But this is perfect to demonstrate why it doesn't make sense. So I run it here. And what students can see is if the mean is lower than the standard deviation, it makes no sense to run a left tail test, because no matter how far it is away from here, it will still not go here. And if it goes in the right direction, well, then the sample mean would be greater than the null hypothesis. So that teaches students, if in this case the sample mean is below the null hypothesis, it doesn't even make sense to run the test, because I know before I cannot reject the hypothesis. That's what I wanted to show to you. I went a little bit fast, but I think if you want to use it in your class, you can go to the video. I will also make a video that I put on YouTube. If you have any questions, please email me. If you like, put teach hist in the subject. I will sort everything nicely in one folder. I come back with my answers if you have an idea. So again, this is really, really different from the big and great tool that we saw before. This is a very narrow tool. It is supposed to be narrow because I want teachers to be able to use it on the fly in the classroom. I wanted to implement so much more, and I said, no, I'm not doing this because I want to keep it simple. I don't want an instructor being in front of the class or myself being in front of my class. I'm absent-minded and struggle with the code. That's it. Thank you very much. And
thanks, Karsten. Yeah.
I'm ready for questions.
Indeed. So we have 4 minutes for questions. I'm going to repeat the one which are in the Q&A. So we have a question from Amelia McNamara, who is also one of the speakers. She just asked in general, why did you choose to use camel case for your function names and arguments?
Just my personal taste. It's just like, it's a way I want to, I don't want to make it too complicated and say you use this case for functions, you use this case for other things to my students. I just tell them my personal taste is camel case. Other people have a different taste, and that's no problem, but be consistent. And I want to make the consistent as simple as possible. That's why I use it also for function.
Thanks. A second question from Janice. She would like to know if it's possible to overlay histograms on each other with a teach hist package.
The answer is yes and no. No, it's not possible with the tool directly because I want to keep it simple. I don't want to add another tool where you can overlay. But you saw that I would type teach hist and then the arguments, and I would push it to the console, and then the histogram is printed. What you can do is you can put the output in a variable, and because the variable is a ggplot object, you can manipulate your data. So you can have, for your one plot, you put it in the variable A, and for the other one, you put it in the variable B, and then you just plot them next to each other. I hope that was a question.
Yeah, thanks. Maybe last question from Luca Vosges, who would like to know if he can get the original ggplot code if you use your function.
You want to have the code of a specific function?
Yes, apparently, yeah.
Just type the function name, and it comes out. And the code is the package is on CRAN. So if you want to make changes inside the functions, you can do that anytime. Does that answer your question?
I think so, yeah.
If it doesn't, or if your question gets more specific, send me an email. I'm glad to help. I want instructors to use it in their classes. I use it also I didn't demo it here, we just didn't have the time. I use it also for exercises for my students. So whatever I do in class, they have to do it at home and repeat it. And I use also LearnR to monitor if they really did it. I have questions about that and so on and so on. So if you have any questions in that direction, please come back, send me an email, and I will help as good as I can.
Thanks. Maybe we have time for a last question. And I can see it disappeared. So, yeah, sorry. Yes, it appeared again. From Davor Prenchik, he would like to know what is the #1 challenge your students encounter in learning to understand histogram?
I think almost all students understand a count histogram. That's not a big deal. Unfortunately, some students already struggle when it goes to percentage calculation, but where they really struggle is when it goes to densities. And I try to explain to them, do not interpret the densities. Just ignore them. Just be happy that your probabilities or your relative frequencies moved from the height of the bar to the area of the bar, and then I can go and explain what are the advantages. You can calculate the integral, and of course I would avoid using the evil word integral. So I think densities is the biggest problem, and that was one of the motivations I made this tool.
Perfect, thanks, Karsten. I think we're just on time. So our last speakers will be actually 3 speakers. The next talk is about the untold story of the Palmer penguins R package, and we have 3 speakers. So Kristen B. Gorman, which is, I think, a research assistant professor of the College of Fisheries and Ocean Science in Alaska. Alison Horst, which is an assistant teaching professor from the Brand School of Environmental Sciences and Management, and Alison Hill, which is, I think, a data scientist, if I'm correct, from IBM. That's correct. Okay. Yeah. So please feel free to share your.
All right. And thanks, Amelia, for setting us up with some penguins early on. So hopefully everyone can see that, and I'll go ahead and play.
Hello, everyone. My name is Dr. Kristen Gorman, and I'm thrilled to be here today along with my collaborators, Dr. Alison Horst and Dr. Alison Hill, to share with you the untold story of Palmer penguins. So Palmer penguins is an R package that features the penguins data set, which you can see here on the right side of the slide. It basically features structural size measurements for 3 different species of Pygoscelis penguins, the Adelie, Chinstrap, and Gentoo penguins. And the information was collected on 344 different individual penguins for things like flipper length, body mass, and also bill length and other types of structural measurements. So it offers lots of opportunities for plotting and really infinite amounts of fun. The R package has been very popular. We launched it in July 2020, and so far it's been downloaded over 475,000 times from CRAN. It's being used globally in courses, workshops, blog posts, and other learning materials, and is also available in a variety of different programming languages such as Python, Julia, and TensorFlow. So how did the Palmer penguins R package come to be? Well, the data set actually originated as part of my dissertation research, where I was working on a fairly large integrative study of the breeding ecology and population structure of these 3 species of penguins that nest along the Western Antarctic Peninsula. And all of this work was done in collaboration with the Palmer LTER program, which is funded by the US National Science Foundation. And for this particular data set, it was originally published in 2014 in a manuscript that came out in PLOS One, where we were looking at how structural sizes were different between males and females, and whether environmental variability sort of drove differences in the ecological sexual dimorphism of these 3 species. And as part of the manuscript, all of the data were made available through the Environmental Data Initiative in an open science spirit.
And unbeknownst to Kristen and the team she was working with, many of us who were working as data science educators were looking for a viable alternative to the classic IRIS data set. And there are a number of reasons why an alternative was really wanted. It was collected in 1935, so it's, coming up on 90 years old. It's used everywhere. It's useful. It has 150 individual measurements for irises across 3 different species. So we're starting to see alignment with some of the features of penguins already. But it's limited in ways too. It doesn't have missing values, so it's a little bit cleaner than what students might expect in the real world. It lacks metadata, which makes it hard to really dig into more interesting questions about the data. It has some unintuitive variables like sepal width. And importantly, it was first published in 1936 in the Annals of Eugenics. So these problematic features and limitations of IRIS made us really want to offer a solution. And some options were like, one, we could keep using IRIS as a data set and use that as an opportunity to teach about some of its problematic aspects. And another option is to find a better data set to actually replace it or to use as an alternative. And the second one is what we were doing with penguins. So many of us educators know well this eternal search for better, useful data sets for teaching so we can bring real world, meaningful data to students in data science classrooms. And serendipitously, while we were looking for this viable alternative to IRIS, I had been looking through the Environmental Data Initiative data sets and had stumbled upon Kristen's penguins data set and incorporated it into some of my classes. And then when Allison Hill reached out looking for some cool data sets, I had shared this with her. Allison ended up writing a blog post that featured the penguins data set. And this quickly devolved into me and Allison just like spending way too much time looking at cute pictures of penguins. So you can see this is part of our Slack message is Allison just saying, so now I'm just looking at penguins pictures, which ended up taking up quite a bit of our time. So we realized as we were looking through the penguins data set that while we were exploring it, while I was plotting the penguins data, looking through more and more penguins pictures, that it really did align eerily well with the IRIS data. We can see on the right that there's a graph of penguin flipper length versus body mass on the left, and then compared to iris petal length versus petal width on the right. So we can see some of these features that look similar across the 2 data sets, and we started thinking this might be a really viable alternative. So the timeline of creating this into a package looks something like this. So in June, I had seen a tweet from somebody, again, expressing a need for an IRIS alternative. I had tweeted like, hey, I think the penguins is a great alternative. Almost immediately after, Allison Hill wrote back, do you want to build an R package? I then soon after deleted the tweet because I realized I wasn't sure on the licensing of the data. One day after that, I reached out to Kristen to make sure that the licensing would allow us to actually share it openly. And very soon after that, on June 8th, our Palmer Penguins Power Team, the 3 of us, assembled for the very first time. That same day, I retweeted with the licensing information. People started using it. And 45 days later, we had published the Palmer Penguins package on CRAN. And now I will pass it off to Allison Hill to talk about making the package.
Yeah, so we had essentially 45 days from start to finish to make this package. And it was really fun to work with Kristen and Allison on it. Some of the things that I think we built into it have made it easier for students and educators to be able to use it. So because we're educators, we made it for educators by educators. One of the things that we built into it, in addition to having the the data easily accessible in R was to actually build in a function called path to file. And this allows students to be able to practice reading in the actual raw CSV file as if it was a local file for themselves. So this allows you to play with typecasting, dealing with missing variables, and all the fun data importing lessons that you would normally use with a local data source. It allows you to do the same thing with both of the Penguins data sets. So we have Penguins_raw and Penguins CSV files built in. And hats up to Jenny Bryan for showing us how to do that in a package with her Gapminder package. We also faced sort of an existential crisis when we were designing this originally for ourselves. We tend to teach, both Allison and I tend to teach with Tidyverse. So we had built it into be presented as a tibble at first, which means that it doesn't dump all the data into your R console when you first call the Penguins. It just prints the first couple rows and it gives you some information about what the columns are. But we were also sensitive to feedback from the community that some people didn't want that dependency and they liked the way that Iris prints in your console all 150 rows. So luckily, we enlisted the help of Hadley Wickham to give us the best of both worlds. If you're running in a low dependency environment and you call Penguins, you'll get a data frame back just as you would with Iris. So you'll get all 344 Penguins in your console. But if you have the Tibble package or the Tidyverse package installed locally on your laptop, your workstation, then you'll get to see the nice Tibble output. So this made us as educators really happy. We also spent a lot of time working on the package down site for documentation. So we worked to make sure that there's a really nice get started to get you up and running with making some pretty plots right away with Palmer Penguins. We also added some additional articles such as examples using ggplot2, a principal components analysis, and we made the art directly accessible as well and download the data directly. So we spent a lot of time making the package down site nice and easy for users. And I think some of that work that we did helped to really get Penguins out in the wild a lot easier. So we've been really excited to see all of the blog posts, the tutorials, the meetups, the YouTube videos, all of the different materials that people have used Palmer Penguins in to make them really awesome. It's been just so exciting to see the uptake in the community. So we asked ourselves, why do we think Palmer Penguins has been so popular? I think one reason is that we made it into an R package, so it was just easy to use. I think it reduces the time to the first pretty plot, which we think also, is what makes Iris a little bit more popular as well. So you can do the same kinds of plots with Palmer Penguins pretty quickly. And I think Allison's art also, which we featured really prominently on the package downside, I think that also made it a lot more exciting for people to be able to do a meetup or do a presentation or include it in a blog post because they had some really nice art to go along with it.
All right, so a couple of reasons that I think Penguins has been so widely adopted is because the data itself has features that are really amenable for teaching, particularly in introductory data science and statistics courses. Some of those things are like multivariate normality and linear relationships. And we also show here on the right that the Penguins data set also has an example of Simpson's paradox in the wild. So showing that the trend reverses between bill length and bill depth as you add species as a variable. And Simpson's paradox is really useful for teaching, but also is sometimes hard to find examples in real world data. And we think this provides a really exciting and approachable example for students to think about it. It also has really good bones for a lot of different types of multivariate analyses that you would want to learn or teach, including for principal components analysis or k-means clustering. We also just show a couple of examples here, PCA on the left, k-means on the right, where we show that there really is similar clustering and trends across Penguins and Iris. So even when we start looking at a little bit more involved analyses, we see that this is really a viable alternative that instructors, educators, and learners could easily adopt if they want an alternative to the Iris data set.
Okay, additionally, I think one of the factors that is made the Palmer Penguins so accessible and widely used is that penguins are just really well loved by everyone across the world. I honestly have never run into anyone who doesn't like penguins. So they're very charismatic species. I think the data that we present on the different structural measurements are quite intuitively understandable. Also, the open license underlies the data, which has made it very easily accessible, not only for us to work in this, create the R package, but also to share it with other people. And you know, beyond the R package and the data that we present, there is a lot of important information on the ecology of the species and how it's relevant to global climate change in Antarctica. So I think the data set sort of opens up perhaps those discussions around global change and how species across the planet are responding to it. So we've really taken this polar research project to a global teaching product, and we felt that it was really applicable or very fitting, I guess, to share our Antarctic data really with the globe through the Palmer Penguins R package. Mainly because Antarctica is a very special place, and it's really an area that has no geopolitical boundaries, and it is a place where the information that's generated from Antarctica really should be shared with the world. We also wanted to highlight that just as a scientist, when we collect data, especially in remote places such as Antarctica, we are collecting information that can be used to build knowledge that we may not even imagine at the time that we're collecting the data. And this was certainly true for my experience, you know, working on my own research project. I had no sense or plan or could never have predicted that it would have ended up in this incredibly useful data science product. So yeah, we're really excited for that.
But thank you all for attending. We're happy to answer any questions that you have, but we'd also like to thank Marty Downs at LTER, Hadley Wickham at our studio for the technical assist there on the R package itself, and then all the people in the RStats community who've blogged, tweeted, visualized, analyzed, taught, or shared about Palmer penguins. We really appreciate the support, and we are excited to hear any questions that you have.
Thanks to the three of us. I think there is one question from Amelia. We would like to hear you speak out the species name one more time, especially the Adelie one. Apparently, some people get it wrong, so maybe I got it wrong.
Yeah, sorry, can you hear me okay? Yeah, so it's Adelie. Yes, a lot of people call it Adelie. Yeah, there's a few different versions, but I say Adelie. That's kind of hard. Yep.
And one thing too, Kristen, I think some people think that the capitalization is wrong in our documentation. Can you explain that a little bit too? Because even in the slides, like the A1 is capitalized, but the others aren't.
Yeah. So, sorry, you're talking about the capitalization of the species names?
Yeah.
Yes. So my experience has been, if I'm publishing, say, in an ornithological journal, I would capitalize the names. Like chinstrap penguin would be capital C with a capital P for the penguin. Adelie would always be capital A because it's a name. But if it's, if we're publishing in a non-ornithological journal, we've always not capitalized the names, except for Adelie because it's a proper name.
Maybe we have a question from Akim Zayles in the chat. Actually, he is wondering if he can find the code to replicate the analysis from the paper about this data.
Oh, that's a good point. So when we published the PLOS1 paper, we made the data available, but the code were not available. And since then, I've been putting code on GitHub for my manuscripts, but this paper came out before I started doing that. So I have all the code. If you want to email me, I'm happy to share it, but it's currently not on a repository. Yeah.
Okay, so go ahead.
I have a question. I use the penguins data set like many other people, but after hearing that talk, I recognized I totally underutilized it. So I didn't know that you can use it for k-means. I didn't know that you can use it for Simpson's paradox. Is there a paper where all this is mentioned that I can read and then see why it's good for the Simpson paradox, which variables? Because there was so much information in this talk, but I'm afraid in 10 minutes I have forgotten most of it, and I just remember, oh, you can use it for k-means, but I would not know why.
I am so glad that you asked that. I promise that we didn't seed this question. But yeah, we actually have a paper coming out in the R journal that includes a comparison of penguins and iris for things like multivariate exploration, linear regression, k-means clustering, and principal components analysis. So the examples that we showed in this talk are all available in that paper that comes, it's all open, all the code is open, and our descriptions of the comparison are all in that paper. So we are really, really excited for that to be published soon.
Me too.
And I just included a link to the draft that is not at all the published version, but you can see the link, and it's an HTML article, so you can kind of click through, and a lot of the visualizations that we showed in the presentation are copy pasted from there.
Great, thank you.
Okay, thank you for all the presenters. I think we are just a bit out of time, so thank you all for your nice presentation. If there are still some questions from the audience, feel free to reach out to the presenters themselves. And I wish you a rest of the good user conference. Bye, everyone.
Thank you.
Thank you.
Thank you